easy. Solve each equation, show the steps. So again, I really want you to get used to, the idea of writing straight lines. No, straight. Here we go. All right, try again. Now, this helps, and I know some of you are really okay with two-step equations, which is good. But those of you who don't remember, right, this really comes in handy. So here's my variable. Identify a variable. Right? Here's a number that is being multiplied by 3, and then 7 is added, and that's going to give me 28. So what's the number I started with? So just like that little problem I gave you in class today, we're going to do it the same way. So to find the number I started with, I'm going to use inverse operation. So the inverse operation of plus 7 is minus 7, and the inverse of multiplying by 3 is going to be divided by 3. So this is your little guide. Again, this does not count as work. It's just a little map, little guide to tell you what to do. So let's write down the equation. 28 equals 3n plus 7. I know somebody mentioned it. I said there's a wall here. One of you guys want to draw a river, that's okay too. So the first thing I'm going to do, and it tells you right here, subtract 7 from both sides, and that's what I'm going to do. Right, so if I remove 7, I don't change, the equation's still in balance, so taking 7 here, that gives me 0. What's left over on the right side is this 3n. And on the left side, 28 minus 7 is just 21. That's done. Step 2 says divide both sides by 3. Well, yeah. Divide this side by 3, divide this side by 3. On the right side, 3 divided by 3 is 1, and 1 times n is just n, and then 21 divided by 3 on the left side is just 7. So that's the number I started with. Check. You have to really check. And trust me, this is one of the nicer checks you're going to do. So what is a check? Well, we're going to see if this is correct, if that value that we found for n is correct. So we're going to replace the n with 7. We get 28 equals, and 3 times 7, right? And replace the n with 7 plus 7. And just see if the expression on the left is equal to the expression on the right. So 3 times 7 is 21. We add 7 to that. We indeed get 28, which equals to 28 on the left side. And that would have been what we're all looking for. Explain the first step you took to solve for n in the equation above. Explain why. So let me go back here. And how the step. Wait, just can't see. Can't read it. Still can't read it. So make this a little bigger. Explain the first step you took to solve for n in the equation, but explain why you took this step first and how this step helped you solve the equation. Plus money, as much. No, the first step we took was to remove, to subtract the constant, right, from the right side. Right, so it made my expression on the right. Hang on a second. Okay, so back to, so the first step was to remove, so we had 3n plus 7 on the right side, right? And we had 28 on the left side. So we want this equation to eventually look like this, to n equals something. And in order for this right here to look like this, right, there are a couple of things that I need to get rid of. One of them is this constant, 7, and then the coefficient of 3. Right. So the first thing I did was to remove the constant. And how do we do that? By using the inverse operation of plus 7, which is minus 7. That eliminates our 7, leaving us with 3n, which is what we have over here. Okay? And then from that, right, it helps me isolate my variable. And the only thing I have to do to isolate my variable, and here's what I mean by isolate my variable, right? There's nothing around my variable except n. And the step after that, again, inverse operation of multiplying by 3, which is dividing by 3, and that's what I did. Okay. Solve and check, and again, we'll solve it, and I am going to do that. I guess I'll call it the story. Here's my variable n. It is currently a number that I don't know. Divided by 4, subtract 7, and that gives me 5. What number did I start with? Well, to find that out, I'm going to do plus 7 on both sides and then times 4 on both sides. So let's see how that looks like. 5 equals n over 4. Minus 7. Here's that river, that wall. Let's get rid of that constant, right? This needs 7, so plus 7 on both sides. That goes away. I'm left with n over 4, or n divided by 4. 5 plus 7 is 12, so that's done. Now my little guide, right, tells multiply both sides by 4. Okay, so times 4, and then times 4. Notice that on the right side, right, I can simplify. So if you multiply across, you get 4 times n, which is 4n over 4. So let me put it over here. N times 4 over 4, right? I can simplify those two, and I'm left with n. So this simplifies to 1, right? Left with n. And 4 times 12 is 48. So supposedly, the number I started with was 48. Let's see if that's correct. Well, to check. Let's replace the n, right, with 48. Put it over here. Over 4 minus 7. And then let's see if the left side and the right side is equal to each other. 48 divided by 4 is 12. Subtract 7. 12 minus 7 is 5. And everything is good. Alright, so this is your basis here, right? So we're going to do equations that are quite challenging and quite multi-step, right? But we want eventually to get it to a 2-step or 1-step. And once we get to 2-step and you're really comfortable with this, everything else is really, really simple. Let's see here. Again, c over 2 minus, all right, I'm not going to copy that. Right. Let's draw the steps, going to check. Okay, so again, it's just more of your practice, right? So here's my variable. C is being divided by 2. Subtract 8. So I started with a number. I divided by 2. I subtracted 8, and it gave me negative 3. What did I start with? Well, I'm going to do plus 8, and then times 2 to figure out what number I started with. So now, let's do that. Here's my wall. I'm going to do plus 8 on both sides, get rid of that constant. So these two go away. Slowly, my variable is getting lonelier. Negative 3 plus 8 is positive 5. Right? So now the second step I'm going to do is multiply both sides by 2. And there's a penalty for Portugal. Oh, sorry. And then let's multiply this by 2. Multiply this by 2. Just like the previous problem, right? This 2 and this 2 simplifies to 1 and 1. And 1 times c is just c. And 5 times 2 is 10. So apparently the number I started with was 10. Let's do a little check. Let's replace. Right, so we copy the original equation. And instead of the c here, I found the value of c. I found that it's 10. Right? Let's see if it's right. So 10 divided by 2 is 5. 5 minus 8 is negative 3. Well, 5 minus 8 is negative 3, which equals to negative 3 on the other side. When solving the equation question 3, how did you use the concept of additive inverse? Here's your concept of additive inverse, right? So let me go back here. Right, so that was in step 1. So you had c over 2 minus 8 equals negative 3. Right? To get rid of this guy right here, to get rid of this, right, what did we do? We used the additive inverse, right? So what number do I add to negative 8 to give me 0, right? Because I want 0 over here. And the additive inverse of negative 8 is plus 8. And negative 8 plus 8 is 0. So that's how I use the concept of additive inverse, okay, to get rid of that constant. That was 4. 5. So, okay, so this one, I'm glad actually we did a problem like this in our examples. Right, so this is one of those problems that sometimes gives you difficulty. Here's my variable, it's D. Now, normally, I mean, if that was positive, right, it could be a very simple problem to do. Here's my river. Let's do the story. Let's assume that D was positive. Here's my D. What's happening to it? We're adding 9 to it. I start with a number. We add 9, and what do you call it? Gives me 11. So what did I start with? Well, the additive inverse, right? Well, plus 9 is minus 9. So I would do minus 9 on both sides. These two go away, and D equals 2, right? It's a positive D. Now, that's not the case here. It says minus D. So D here, and then here's maybe you want to put a 1 here. D is being multiplied by negative 1. We add 9, and then it gives us 11. So it becomes a two-step equation. The inverse operations that we're going to use to find our starting number, it's going to be first we're going to subtract 9 from each side, and then we're going to divide by negative 1. Okay, so let's do that. So negative D plus 9 equals 11. So step 1, here's my river, my wall. Subtract 9, right? The additive inverse of plus 9 is minus 9. So subtract 9 from both sides. I get 2 over here, and these two go away, right? That's 0. I'm not going to write it down, but I'm going to bring negative D down. I don't want negative D. So we did step 1. Step 2 here says divide both sides by negative 1. So divide this side by negative 1 and divide this side by negative 1. There's an invisible 1 here. So negative 1 divided by negative 1, it gives me a positive 1. And positive 1 times D just gives me D. And 2 divided by negative 1 is a positive divided by a negative gives me a negative. And 2 divided by 1 is just 2. Okay. So let's do a check. So we have negative D plus 9 equals 11. You have to be really careful with your check. So here's that minus sign is already there. So I'm replacing D with negative 2. And I'll put that in parentheses. Now you can see why that equals 11, because those two negatives will give me a 2, right? Positive 2, and then plus 9. 11 equals 11. All right, so part B you can explain. And then we have an error analysis. Okay. Danny solved the equation 13 equals 10 plus 8 and found that m equals 2. Consider Danny's work below. Is it correct? And I guess because it was, let's see. So let's do it ourselves. It's always easier to do it ourselves. So the first thing, here's my wall. Well, here's my story. Right, here's my variable m. We're multiplying that by 10. Here's a number that I don't know. I'm multiplying that by 10. I'm going to add 8 to it. It's going to give me 13. So to find the original number, let's go backwards. So I'm going to subtract 8, and then I divide both sides by 10. So let's subtract 8. If you subtract 8 from both sides, these two go away, right? And I'm left with 10m equals 5. Is that what she has? So far everything looks good. She did subtract by 8. Look, subtract by 8 on both sides. So far good. And then she got m equals 2. Oh, let's see. Well, step 1 we did correctly. And then we're supposed to divide both sides by 10. So let's divide both sides by 10. Divide that by 10. Divide that by 10. 10 divided by 10, right? Go away. And I'm left with m, which is what I want, right? M isolated. My variable isolated. And then 5 divided by 10 equals 0.5, or I don't know, some of you rolled a half, that's fine too. Now she got, I don't know if Danny's a boy or a girl, well she got 2, m equals 2. So what do you think was her mistake? How did she get 2? Maybe she divided 10 divided by 5? I don't know how she got 2, because this is what she had. And then if you divide both sides by 5, right? This 5 divided by 5 is 1, and here 10 divided by 5 is 2m. That's not the answer yet, because I still don't have my variable isolated, right? M is not by itself. There's a coefficient of 2. I want a coefficient of 1, so I have to still divide this by 2 and this divide by 2. So I don't know what exactly she did here, but she didn't do the step to correct. So do you agree with Danny's answer? No. Right? She was okay up to the first step, up to here. She was okay. She didn't divide both sides by 10. I don't know what she divided both sides by to get 2. So that's the part that she got mistake. So how you can for me check if Danny's answer is correct. Well, here's how I know she's incorrect, because I did it myself. What mistake did Danny make? I really don't know how she got 2, but I know that we're supposed to divide both sides, right? After we get to this point where 5 equals 10m, we're supposed to divide both sides by 10 to get rid of the coefficient of 10, right? To leave m by itself and to get an answer of a half. Okay, so that's it, I think. Yep, that's it.